So, good morning, everyone. Thank you all for joining us for this webinar, to engineers, to the architects, to the healthcare professionals, to all our special guests. Again, thank you for joining us and welcome to this webinar. Let me introduce myself. I am Norman Tai, and I am the Civil Division Chair for the Jamaica Institution of Engineers. And as we kick things off today, I mean, COVID-19 has or needs no introduction. It is a disease that has affected each and every one of us in some way, whether directly or indirectly. And it's just upon us now as the requisite technical expertise to come together and see how best we can create the response mechanisms to ensure that we have a fighting chance in this pandemic. So the Jamaica Institution of Engineers is extremely happy to have everyone on board and to be able to facilitate this collaboration with the team from Politecnica. They are an Italian engineering and architecture firm. And a little later on, you will hear more from them and what their team does. So we are grateful to have this opportunity to facilitate this knowledge sharing forum. And without further ado, I would want to invite our president of the Jamaica Institution of Engineers just to bring short greetings, and then we can move into the program. So I'll now invite President Glaister Ricketts of the Jamaica Institution of Engineers to give his opening remarks.
Thank you very much. Good. Thank you very much, Engineer Norman. Good morning to everyone. So happy to see you all. Ms. Stacy and Denison Heron, President of the Jamaica Institute of Architects. Mr. Marlon Jones, Director, Health Facilities Maintenance Unit in the Ministry of Health and Wellness. Ms. Molly McGann, Administrator, Health Infrastructure Standards, Ministry of Health. Engineer Ania, Partner Engineer, Head of International Business Development at Politecnica and his team. Other engineers, architects, healthcare professionals, and all other guests, good morning to you all. I bring you greetings on behalf of the Council and members of the Jamaica Institution of Engineers. In my inaugural address as President of JIE, I alluded to the very challenging times we now face and how COVID-19 has caused significant changes in every facet of life as we knew it. This, admittedly, will be our reality in the coming months as we continue in this fight against COVID-19. Despite these challenges, however, the pandemic in many instances and across many sectors has and will continue to initiate innovation, ingenuity, and resilience in our people. The role of the engineer cannot be downplayed in this regard. The engineer must continue to integrate new information and advancement in the field of patient care in order to streamline processes, improve the administration of treatment, and improve efficiencies of the physical plant. As we respond to COVID-19 and other emerging issues, this need for continuous optimization of the various systems within the healthcare facilities has led to the unearthing of new and relevant knowledge and practices. The Jamaica Institution of Engineers exists to promote and encourage the general advancement of the engineering profession and the practice and science of engineering, and to facilitate exchange of information and ideas among its members and the public. This morning's webinar, Architecture and Engineering for COVID-Proof Hospitals, is a great example of initiatives and programs we wish to undertake in order to fulfill our mandate. Permit me then to duly recognize and thank the team from Politecnica, which engaged the JIE through one of our very own members, Ms. Engineer Murdoch, and proposed this knowledge sharing forum. We eagerly look forward to the insights and information you will share with us this morning. We also acknowledge the partnership of the Jamaica Institute of Architects, the representative from the Ministry of Health and Wellness, as well as the technical representative from the various healthcare facilities. Undoubtedly, you will play a particular role in the conversation as designers and end users of these infrastructure. Thank you for joining us, and we look forward to a lively and engaging discussion. Have a wonderful day. I now hand over back to you, Mr. Chair, Engineer Norman.
Thank you very much, President Ricketts, for those opening remarks. And again, I just want to welcome everyone to our webinar, Architecture and Engineering for COVID-Proof Hospitals, the Italian Experience. Thank you all for joining us. So on the other side of the design spectrum, if you will, we have our architects, and they are just as crucial in this discussion. So at this point, I will ask the president of the Jamaica Institute of Architects, Mrs. Stacey Ann Dennison Heron, just to give her greetings and her remarks. Mrs. Heron? Right.
Thank you. So President Ricketts, Engineer Norman Tai and his executive team, the other JIE representatives, representatives from Politecnica, to the MOH healthcare representatives on the panel, other guests and participants, a pleasant good morning. It is with great pleasure that I bring greetings from the Jamaican Institute of Architects, as we are the professional bodies that join together in forging the way and path for development in Jamaica. It is no secret that the JIA and the JIE have had a mutual interest in the built environment in Jamaica, and the best interest, especially in this time, is what is needed. We're both committed to upholding the highest standards of practice and conduct, and we would like to enforce to our members that the importance of the profession to be for integrity, technical, and artistic ability. With the current COVID-19 pandemic issues, it is only expected that, like others around the world, that we look at creative ways and innovative ways to address the issues in our healthcare system. We welcome the knowledge sharing from Politecnica and look forward to learning new things, as well as to growing as we improve this sector in Jamaica. Thank you, and we look forward to, and welcome, and look forward to actually meeting at some point in time in the future. Thank you.
Thank you very much, Mrs. Dennison Heron. Indeed, we look forward to meeting when COVID-19 is all done and we can shake hands and share more of our experiences and knowledge in some other platform. So we're definitely looking forward to that. And so we move on to our healthcare professionals who, of course, they are essentially the end users of the facilities that we as engineers and architects design. And so they, as with the architects and engineers, are crucial to this discussion. And with us, we have a representative from the Ministry of Health and Wellness, as well as other professionals and engineers from the various healthcare facilities. And it is quite timely, I believe, because I understand that the Ministry of Health and Wellness is also looking into guidelines for the design of healthcare facilities across Jamaica in response to COVID-19 and other emerging issues. So it's quite timely, as I said. So at this moment, I am going to invite a representative from the Ministry of Health, Mr. Marlon Jones. He is the director of the Health Facilities Maintenance Unit from the Ministry of Health, and he will just giving us a perspective of the Jamaican healthcare system and our facilities and how we really have been managing with the COVID-19 pandemic thus far. So without further ado, Mr. Jones.
Sure. Thank you all. Thank you to my JIE colleagues. Thank you to Politecnica and to all participants. Thank you for being here. We just have a short presentation that we'll just probably go through just to illustrate the environment in which we work in, what were some of our challenges, what were some of the basic solutions we came up with, and just give you a way forward. So let me just share a basic screen here. All right, good day, colleagues. So welcome again. So we're just going to basically start out with telling our healthcare delivery system, how is it actually set up here in Jamaica, and how is it that we actually deliver healthcare. We are divided basically into 3 categories, which is primary healthcare, secondary and tertiary, and special. Primary healthcare consists mainly of health centers. Secondary and tertiary are mostly the hospitals. So type A, type B, type C's. And we also have special care. Specialist care are primarily those that offer pediatric, mental health, and chest-related issues. This is a basic breakdown of the locations of our hospitals and health centers. We have about 300 health centers and roughly about 23 hospitals. As I stated before, hospitals are divided in different types, and it depends on the bed size and the type of service that they deliver. Type A, we have 3 type A's, and those are the tertiary hospitals. KPH, Cornwall Regional, and UE are the 3 type A hospital that we have here. And for the others, we have type B's, type C's, and those indicate the type of service, as I've stated before, and also the number of beds. Hospitals and health centers location are normally determined by population size. So population is the way in which we determine where a hospital will go or a health center per se. I think we're moving a little bit now to also use other evidence such as epidemiology to determine exactly where some of these health facilities are placed. Also, we have specialist hospitals, and I did name a few in the previous slide. We have a pediatric hospital, Bustamante Hospital for Children. We have a mental health, which is Bellevue. We also have a hospital that is dedicated to respiratory disease, which is the National Chest Hospital. And I think now we're doing an additional hospital, which is the Western Child and Adolescent Hospital, which will be based down in St. James. Here is an illustration of how the health system actually operates, how a patient actually moves from one type of health facility to the other. Primarily, and what we desire is that the first point of contact would be the primary care, which would be the health center. And from there, if the issue cannot be resolved, the person or the patient will then be referred up to the system. So primarily, the health center is the point of contact within the health system. Let me just give you a brief overview of how engineering, both civil, electrical, mechanical, and architectural services actually delivered within the healthcare system. At the top of the food chain is actually the head office, which is Ministry of Health, primarily responsible for policy planning, monitoring, evaluating, and just giving policy directive overall. Then we have the country is then divided into 4 different regions, which is Southeast, Western, Southern, or Northeast. They are actually operational, so they do the day-to-day implementation of the policies that are determined by the Ministry of Health. It then further breaks down into parishes to some extent, and a lot of the regions, it is actually decentralized, so they have a little bit of flexibility in terms of what is the mechanism they actually utilize to implement the policies that are developed by the head office. Basically, in-house, technical capacity range from civil engineers to biomed engineers to mechanical engineers to architects to quantity surveyors to maintenance technicians, environmental engineers, different type of engineering services. Also, in terms of the design, presently, I know Mr. Norm actually spoke about the guidelines that we're actually developing. They are still in the infancy stage, but I think we have made some progress. But now, what we actually use to determine how hospitals are built and designed, primarily from the Jamaican Building Code and the Jamaica Building Act. We also take into consideration climate conditions, disease-based transmissions, and international guidelines and best practices. Some time ago, I think we bought the Australian standard, but we do look at the European standard, and we do look at the American standard when it comes on to actually build. Our basic facility designs for the different type of health facility. We normally follow the building code. Our facilities are normally single or double structure, double level structure. It might differ. For instance, you might see Carnal Regional, which is multi-story, KPH also, I think Mandeville, but other than those, it's normally the single or double structure. Our facilities are normally made from concrete, which is give us about 50 to 100 year lifespan. For ventilation, it is normally natural, except for those specialist areas, which ICU, operating theater, HDUs, labs, those areas that require specialized air filtration or negative or positive pressure, that is normally accomplished through some HVAC system. Try also to make our walls to be monolithic and smooth and water resistant and easily cleaned, just for disease control purposes. Also look at the spatial design and looking exactly at equipment placement to achieve efficiency and overall efficiency. For the monitoring services, for instance, when we're building a new health facility, what we normally rely on is normally the parish council, NEPA, which is the National Environmental Planning Agency, the fire department, the government electrical inspectorate, National Water Commission, etc. Also, Ministry of Health also play a part through the Nursing Home Act. So, for instance, policy and planning department, standards and regulation, they actually go out and inspect new hospitals and give a registration, normally under the Nursing Home Act. Environmental health unit also play a role in the inspection of new health facilities. For the next slide, basically we're just going to point out also what are some of the structural changes and engineering changes we did made during the COVID period. For building design, we did increase our capacity in terms of specialized space. We had 4 ICU at the beginning of COVID. We still have 4 ICU practically. The main purpose for this is that the ICU within itself require more than just a physical space. It requires equipment and personnel to actually carry out the overall function. So it's not quite easy just simply to just build a space and operate it, because it takes additional support service to actually go in, have it up and running. I think we chose to go a step further down, which was HDUs. So we moved from about 2 to 7 HDU, because these can be operated quite more easily than the ICU in terms of what is required. We also looked at changing the way in which we create isolation rooms and HDUs to make them multifunction. So we could switch from positive pressure to negative pressure by just a flip of a switch. And that wasn't what we were thinking prior to this. So we could use the space for people with immune deficiency, and also reverse and use it, the space for individuals who have infectious disease. And this is one of the limitations, because we can't build purpose-built or dedicated space. We're a small country for just infection control only or immune deficiency. So how we can actually use rooms based off the need, even after the pandemic. Sustainability in any design that we have done, because we do recognize that at some point, hopefully this will go away and we will need to use those spaces again. So, all right, additional space requirements. So we made holding areas. Some of these temporary and outside, for instance, using tent and other items. We constructed some isolation rooms that can be utilized even after the pandemic. We did some infection control by using materials that are impermeable to water resistance, the chemical. We also installed some hand wash stations in places using foot pedals or elbow action where it wasn't possible for us to get the additional foot pedals, etc. We also work with our architects to actually revise the flow within the building to see how best we can have unidirectional flow or have limit the amount of cross contamination. So making multiple entries where there was only one. We also installed barriers for customer service person or persons who come in directly in contact with patients who don't need to physically touch them themselves. Supporting service counters and other things. Also did spaces to avoid overcrowding and zoning of the areas, to ensure that people aren't clustered together. But those are some of the basic steps that we took overall to help us fight against the pandemic, or to control it per se. For the next slide, we're basically looking on the way forward, and the way forward is for us to actually develop some policy directives. The guidelines, as spoken before, is one of those that we are working assiduously in order to achieve, to actually have guidelines to determine how health facilities are actually built, how they should be maintained, what are the basic specifications, for instance, for operating theater, for a lab, type of air conditioning system, the type of equipment, developing risk management plans for just the day-to-day operations. So those are some of the things that we want to concretize in the future, and working very hard towards that. And this, sorry, and its complete aspect is utilizing health technology assessment. And this is something that I know PAO and the World Health Organization is pushing heavily, which is how do we use evidence-based to determine the type of technology that we deploy within our healthcare system. We're looking at the total life cycle cost of owning or implementing a particular technology so that we can determine whether or not it is best fit for our environment. So we would take into consideration cost, culture, manpower, or budget, and then utilizing that as a way to determine which technology is best fit for us. Not because it's being utilized by a particular country, it means that it will be successful here in Jamaica, because we might not have a different type of culture in which we operate, and we might not have the budget to sustain it, might not have the manpower and the technical skills to actually achieve it. So utilization of health technology assessment to determine whatever we utilize in our hospitals is one of the primary things that we want to utilize now in determining how is it that we implement the different solutions. Also, we need to ensure that whatever we do is sustainable, can be utilized after after we have overcome this pandemic. So whatever we buy, whatever we implement must be sustainable. It must be something that can be easily integrated into the day-to-day operation of the hospital and bring some additional value. Can't be that we just do it now and then just throw it away. So we need to keep in mind that when we implement any solutions overall. We need to develop a roadmap after we have decided all of that. How is it that we are planning to implement the different ideas? How is it that we move forward? And implementation overall require training, recruitment, and financing. But for the technical personnel, such as the engineers and the architects, because we recognize that they themselves are going to make decisions, but they must be aware of all the inputs in whatever solution that they are deciding to utilize. As I said before, what are the financial ramifications of implementing this compared to implementing that? What is the manpower requirement of implementing this compared to what is the budget? What is the culture in which you're putting it in? And that requires training, getting the right personnel, and having the right financing to overall implement the ideas. So that is just a synopsis of what we have done over the period. So thank you all for allowing us to just put giving our opinion in terms of what is it that we have done so far. Thanks.
Thank you very much, Mr. Jones. You definitely have given us a fulsome and comprehensive perspective of our healthcare sector here and how we have been treating with the pandemic thus far, and indeed how we plan to move forward. And I'm sure the information that you have shared with us will be beneficial, particularly with the team from Politecnica, and how their experiences may relate to what we have experienced thus far and how we can collaborate and move forward thus far. So
thank you very much.
Yeah, man, thanks again for being here with us. And I just want to point out as well that we have a number of, as I said, healthcare professionals and engineers and architects who work directly with the various healthcare facilities, who work within the Ministry of Health and Wellness. I also want to point out Mrs. McGann from the Ministry of Health and Wellness, who was able to facilitate the team from the ministry in joining us today. So thank you, Mrs. McGann. And without further ado, I want to move on to the team from Politecnica. But before I do so, I just want to remind the attendees that as we move into our technical sessions, Please feel free to post your questions and your comments in our Q&A and chat sections. Our moderators going forward will take note of these questions and comments. And at the end of each technical session, as much as can be accommodated, we will ask these questions to our presenters. And going forward, our moderator will be Engineer Kellesia Banks, and we should also have Engineer Godfrey Boyd on board as well. So if you hear a different voice, just take note of them at the end of the technical session. So without further ado, I would like to welcome and introduce Enya Sermazi. I hope I got the name correctly, from Politecnica. And he will just introduce his team and just give a little bit of the description of what their company and their organization has been doing thus far. So, Mr. Sermazi, I hand over to you.
Yes. Thank you. Thank you, Mr. Tai. Good morning, everyone. And we are very honored to be part of this webinar. So I would like to thank, first of all, Mr. President Lester Ricketts for supporting this opportunity and all the JIE staff for making this organization possible. We're very honored to share our experience, to see also here a president of the institutions of architects and the authorities and Ministry of Health representatives. So we're very glad for this. I will briefly introduce our company and why we are here, how the idea of the webinar was created. My name is Enea Sermazi. I am one of the directors of Politecnica. Politecnica is an Italian engineering and architecture firm working in the building sector, based in Italy, working abroad. We are presently working in Jamaica as well, and in the CARICOM region. In Jamaica, we are working in a project, in a joint venture with a Jamaican engineering firm, GDM Associates, managed by engineer Gawain Murdoch. And we have a division dedicated to healthcare facility design that is in operation since 1972. And the idea came out because we were one of the companies called by the Italian authorities in spring of this year in Italy, when the first wave, the first heat of COVID struck the country. And nobody was prepared. And so the very first phase was very tough in terms of response. And so everybody was called to give a contribution. And we as engineers and architects had to give a response to the authorities, who were making many questions and trying to understand which was the best solution due to the strict time, due to the budget constraints, to be implemented. So it was very interesting to hear the presentation of Mr. Jones, because we could have a better insight of the Jamaican healthcare system and the present response of your country to the pandemic, because we see and we saw in the spring that despite the differences between the healthcare systems of each country, there are many similarities in the questions and in the decision-making process. So we thought it was very interesting to share this experience, because it's true that the COVID is spreading by sharing the physical proximity, right? So we said, why don't we share the technical knowledge to fight it? And that's why we propose and create and organize this webinar. We're talking about us, a community of technicians, engineers, architects without borders, because we have experience altogether that COVID has no border. So we need to share this knowledge, and we thought that it could be beneficial to share this, to get some inspiration, some insight, or just to understand if there might be innovative ideas, or which are the most common questions, what was the strategy used in other countries, because many questions are the same. So where is the best place to locate a COVID facility? Close to an existing hospital, far away in a greenfield, Is it better to build a new facility or transform an existing facility? These are the answers that our staff will give to you in the next sessions. I'm just making a very short presentation of our staff who will present the next phases. Miss Claudia Romero is our Chief Hospital Architect of the Healthcare Division, and she took part in the emergency response of the first wave in April. And she's now taking part in the second wave response, because while I am speaking, Italy is actually in a second lockdown, and the peak has already passed, but we are still in the descending phase, and we could experience that there is also a different perspective from the point of view of health authorities in how to manage the response, because now in the second wave, we are more prepared than in April. And so we could see that, as Mr. Jones was pointing out for Jamaica, there is a common tendency now to make midterm views and midterm strategy. So we are designing COVID-proof facility now, but can we reuse them? How can we recycle them? Not only for COVID, if other waves will come, but also for other types of pandemic. So we are assisting to a small revolution also in the decision-making process of the health authorities that is guiding all professionals in the request for them, for their services, with different objectives on a wider range of possibilities and scenarios. Then in the second session, the first session will be dedicated to COVID-19 architecture, impacts, traditional solutions against innovative solutions. The second session will be presented by our chief engineer, Marcello Gusso. Marcello Gusso is a HVAC engineer. He's been designing for more than 20 years HVAC systems for hospitals, clinics, and medical centers. So he took part together with Claudia to the design of the transformation and the building of new facilities for COVID-proof hospitals here in Italy. I will give the floor now to Ms. Claudia. We'll thank you again to JIE for hosting this initiative, and we will remain, of course, at your disposal after the webinar for any inquiry, clarification, or deeper insight that all attendees might want to explore. Thank you very much again, and I would give the floor now to Ms. Claudia Romero for the COVID architecture session. Claudia, you have to switch on your mic.
Hello?
Okay.
Okay. Hello, everyone. Thank you for your participation. I am Claudia Romero, as my colleague Enea Sermasi was saying. I am the chief responsible of health planning sector inside our company. And let's talk about company experience. Is what we have done in this month from the 21 of February, when we knew about what was this new story was to start. Non mi cambia. Okay. There are about 8 important facts that has left a mark in history worldwide. Hiroshima bomb, Human Rights Declaration in 1948, the mapping of the human genome, and in 2020, COVID-19 is already a fact that has the relevance to change history And from nowadays, it can be said before and after COVID time. So, during the lockdown, we had a lot of time to think. We were close in our homes. As designers with the responsibility and the wish to do something, our company started doing some internal meetings. And just to answer the question, which are the strategies? What can we do for this emergency moment? A lot of things could be done, but we were closing our company. We have the opportunity, being in contact with regional authorities, to think about strengthening the response of the National Health Service in hospitals, aimed at adequately coping with the epidemic emergencies, and to give an answer of a specific reorganization plan guaranteeing the increase of activities in the hospitalization regime, in intensive care, and in areas of care-intensive assistance. There is in this moment a big difference. We need to think that we were in February in this was the peak of our situation, and here we are in the middle of March now. But now that we are in the second wave, the approach is really different. So I will talk a little bit about what happened in the first wave and what we are doing now in the second wave. Okay. So the question in that moment was what to do, where to do it, how to do it. The emergency, I think that Italy was the second country in the world that is starting to have a lot of population with COVID-19. So we started to do we started to talk with the stakeholders, okay, doing research in order to help them to think as quick as possible to take decisions. And the most important thing was, okay, we need to increase intensive care beds, but where? How many beds we need to increase? So, as it was said before, population is the answer also of how to organize our hospitals. We started to work with Emilia-Romagna region, that is a place where we have our main company office. And the first number was, we need to think about 144 beds of intensive care services for this region. So in that moment, think about March, where everything was in a trouble, where people had a lot to fear. We were scared of us, what to do and where. So we start thinking that and helping people, saying, okay, 144 beds, put it all inside in a structure, an existing structure, maybe it's not the better answer for the problem that we have in this moment. Why? Because we cannot think about only intensive care beds. We cannot think about only the patients that have the problem in that moment. What is happening around these 144 beds? We need to have another type of organization. We need to have all the emergency needs, and it's not the bed. It's not some other places around that. It's a really big and important organization. We need emergency assistance, we need pharmacological assistance, intervention assistance, logistic assistance. So As you can see in this image, we started, of course, to try to verify. This is an exhibition facility area where about 6,000 square meters, where we increase, we have the proof of trying to put 144 beds, but we didn't have logistics, as I was saying before. We didn't have the staff. We needed to have a big spaces around. And also in the same way, we start trying also with sport facilities, because I think that the whole community wanted to offer to do something. So sportive areas were also giving their space. In this case, this was another type where we could also try to place these 144 beds. We started thinking about flows, as Mr. Jones was saying before, entrance for patients, staff, logistics, accommodations, and we start working with some modular prototypes just to reuse these ones, and to with these standard modules we could build whatever we need. These were particular standard modules of 10 beds only. There was something important. In the meanwhile, the emergency was going on. There was one particular element, that was the time to know the answer for swabs. In the beginning, we needed to have 72 hours, 48 hours to need the answers of a swab. In ongoing the days, the time of answer of a swab was reducing. So this determined that there was a more controllable emergency situation. So we understood that we didn't need to have all these beds inside one place. Maybe the better idea was to divide these 144 beds in different hospitals. So in that way, we could make a better distribution of patients in all the region. In that way, we start thinking about free places inside hospitals, or maybe free places or not well-used places inside existing hospitals. So in that way, the answer that we needed to give was another one: how to organize with prefab systems inside the internal hospital areas. How were the best technologies? So we thought about, and we use, of course, pneumatic structures, but they were only used for triage. We didn't use it to put them beside hospitals. Another, and this was really a good answer, because it was really quick to have these structures in a quick time. When you think that 15 days in an emergency moment is not, it's not really quick. We needed to have these elements. Another idea was shelters. The problem of shelters was time. We had the producers, the suppliers said they couldn't give it us in not less than 60 days. So this was really trouble. It was not useful for Italian problems. So we start to think about prefab external modules, and this could be a good compromise, because they were practical to do, but as well as we were saying before, we needed to give a double answer. The answer was for the actual emergency, but nowadays, with everything that we do, we need to also think in the future. We need to think of the mission of the 2030s. In the future, we need to think that what we are doing now should be our mission should be that we could maintain it for the future. So, Politecnica company start to think about what to do inside to organize prototype modules, how these modules could be combined to give answers internal of structures or external and beside existing hospital. It was here you can see how we can combine these modules. These modules were has military measures. We were talking about 2.30 and 6 by 6 meters. So in that way, any supplier could give a proper answer of what we need in any different hospitals. We could organize it in a rectangular shape. We could organize it in a square shape. And this that is what we did. These decisions of using, we divide these 140 beds in 5 different hospitals. In 3 hospitals, they try to reorganize internally in existing areas, and only in 2 hospitals, the regional authorities agreed that they needed to build new modules. Think that there is in the beginning of May, there was this type of analysis. We have that actually we had 3,500 of intensive care units. We need to increase also 4,225 beds for sub-intensive therapies. And the most important thing is that we cannot only have new hospital or new structures. The government needed to make a plan to take out 490 million for remuneration and hiring a new staff. This is really an important thing, because also about talking about structures or medical equipment, and we need to talk that these new staff need to be formed. We need to organize new educational course inside of universities and yes, university course and hospital course. So now I want to talk you. So this is what we have been done in the first part of the first wave. When the regional stakeholders decide that it was okay, we need to build these new prefabricated ICU centers, we, our company, decide to donor this design, and we start working together with these regional hospital offices. Okay, so we start with a small ICU prefabricated module that was for 18 beds. It was placed, you will see next, beside the Bajubara Hospital, beside the emergency area. Our roles were, of course, efficiency, lymph flows, isolation path, flexibility. I think one of the most important things is how architecture can be helped with the empowerment of mechanical technologies. Also, as we were talking before, ideal place to work, low risk, high safety space to work, low risk of infections, and not the less empathic, less stress, empowerment, and as your Ministry of Health is well-being, a very important word. So this is one of our experience. This is the Bajubara Hospital. It's a general hospital, and this was the place that was strategical choose to put the new prefab ICU module. This is the emergency area. We did for 18 beds a module of 590 square meters with an analog, a similar surface, 475 for technical and mechanical areas. It was important because we needed to reorganize the path and flows of patients to ensure that they are taken in charge safe, avoiding the contagion of other patients, including sub-intensive therapy course and not COVID-19 related patients. This is as we have organized our flows. This is really, for us, was really important because in the meanwhile, we have been going inside in several hospitals, looking which was the way they were working, how they were taking assure the safety of the staff. And of course, about personal protective equipment, this was the most important thing that in this moment makes the difference between a standard ICU center from an infectious center. So, if we can stop a little bit in this image, we can see that we have in green area, the clean area, we have the entrance of staff, where we have an access control door, we have clean storage, we have changing and dressing areas, and we have airlocks, filters with different pressures where if you not close one door, you cannot open the other door. So it's only the internal staff that can take the clean material to work inside the ICU open space. We have the control room outside, so we can see through a window what is happening inside this area. But we have given the double monitoring system outside and also inside, because this could be changed in the future when we hope we will not have any more COVID-19 situations. This could be a standard intensive care area. We have the undress area. This is, we think, is really a strategical place, the undress area, to take out the dirty and the waste. In the dressing room, it was really important to see that we have a lot of materials, much more from what we had before. And sorry, and a really important thing is the place where we need to hang all the all these new devices that we need from now on. Shelves and furniture to hang helmets, a lot of outlets for equipment recharge. We need to have a recharge for ventilation of helmets, and these were things that we didn't have before. So this, we assume that is for electrical planning is really important. The other thing is, I think the most particular is the undressing area, because if it's not band sized, if it's not well placed, it can, is the very big risk of high contamination, and I think is really important. The staff, when goes inside, is scared, they are afraid, they are stressed. In the meanwhile, if you are stressed, maybe you don't work with the plenty of calm that the patients that are inside needs. So we need to find places, the undressed place need to be a really sure place for staff. And another thing that is a very long procedure. So it's, if we have plenty space, we have enough place, we are helped to undress. This is an important topic, an important argument to put inside our projects in the future. We have noticed that in different hospitals we have different types to do the things. We have undressing even inside of intensive care units, open intensive care units. You can see we have this boundary line. In this area we have people with dress, and in this area we have people that is in green. When I mean in green is where you don't need any other protection. In our projects, we prefer not thinking anymore to emergency, thinking in the future that we need to have a division, a glazed division, where the staff that is in the dressing area can help to see if the staff that is in the undressing area is using a very good procedure, because the important thing is that we have learned is that the 70% of contamination of staff is inside the undressing room when they take off all the dress. So in some existing hospitals, they organize, as you can see, with diving suit inside the patient's area and without diving suits beneath, even if they were inside the same room. Of course, if we can do it, we do it with this glazed division. Another thing is how to manage the waste. Of course, now on, in the future, we will need much more surface to organize the flow work inside intensive care areas, because we need to respect the protocols, the safety protocols organization. So never more we can not have the plenty space that we need to use. In this case, you see, it's important for us now that the waste not comes out. So we need to change this in continuous. We need to make, we need to clean some medical equipment. Even the first cleaning, it's inside the waste, the intensive care area. Then we will have a second area where the people will make the second and the third. We need a lot of time for medical equipment, for people. We will have another staff inside. Of course, a lot of more places, a lot of more sockets. We will have, now that we are dressed, we need to have elements to phones, internal phones, to communicate. So we have new elements, and we need to have a lot of much more devices inside, because it's important to reduce the number of times that you go inside and outside from the intensive care area. So much more space. Think that our standards have been changed, and in this region in particular, we need to have 2.5 times the surface, 2.5 times of general service of the surface of the intensive care units beds area. I mean, if you have 100 square meters for beds, you will need to have 250 square meters just for general service in order to guarantee a safety work in progress for the staff. This is how our intensive care unit open space is now. We have started, we finished our design project in 2 weeks. The regional authorities did make a tender bid, and in 2 months this was already built. Actually, we have the patients inside, and it is working since 2 months ago. Here, as you can see, this was an emergency situation. We need to hurry up. So the place that we choose, that the one that you saw in red in the other slide, was not as much as big as we needed if we were building this project now. Okay, so the distance between beds, even if it was in emergency, was 1.60. And actually, in this region, the distance must be 2.50. So this is really important, the distance between beds, in order to, again, to guarantee that the staff can work in a safe way. Another thing was we had put for each 3 beds 1 dialysis point in order to avoid going outside from this area. Even if it was an emergency, it was we could work, of course, with trolleys and to put all the ventilation devices on. But we decided that was better because we need to think in the future. We are using money to do these things. These things should be used in the future. So we agree with the staff to have medical handling units, double ones. And another thing is to have lifters, always to guarantee safety for staff. And this is all the devices that we have inside this area. These were 18 places altogether. This is the process of new construction, and this is, as I was showing you before, how it was the finished situation. I want to try to show you this video. Non si vede.
Claudia, I think you can go ahead.
Okay, sorry, we cannot see, sorry. It's a pity. Okay. So let's go on. After these 2 months, when we finish that module, prefabricated ICU, we did another project. In this case, was the second module that the region was asking for, and this was about 30 beds inside. So we used it, this was a new area, this is another big general hospital, it's about 400 beds, and they wanted to have, as we choose and propose in those meeting moments, to have this outside the hospital, with, of course, a connection with the existing hospital, because we needed to have a connection with operating theaters, diagnostic, etc. This was our situation. Starting, we need to take off trees, children areas. It was a lot of things that we needed to do, and as you can see, we have here double modules. They are similar to the first one that we show you. In the middle one, we have the technical electricity areas, and in the surroundings, we have mechanical device and mechanical plants on here. In this case, because we had more time and the emergency wave was going down, here you can see that the stakeholders decide that we needed to use the money that we have that we had in a better way. So in this case, we didn't use 1.6 meters between beds, but 2.40, even if we were in emergency. So this is how you can see, this is our new module. We have finished this one 1 week ago, and actually it's already full of patients, because actually in Italy we are in our second lockdown, and this region think that is open to patients from another regions. They are not only from this one. In this case, you can appreciate the much more space that we have between beds, how it's better to work, and we have also beds for bariatric patients. Here is a view from the control room, and as I told you, we can have control from inside and from outside. A new thing inside of this, because we had much more space, is the introduction of bio-contamination rooms. So we can have not only COVID, but we could have inside COVID and some other people, some other type of infectious disease. So we have in one of the modules 4 of these rooms, and in the other one we have 2. So for 30 beds, we have 6 that can be placed inside these biocontamination areas. These are done with glaze to go inside, but as you can appreciate, the pre-filter is done with a plastic PVC material that can be, we can do decontamination, we can clean it, we have the place where to throw out the waste in safety, and we have control access to go inside. Another important thing that the government actually is thinking about, and is there is some amounts of money to give these particular stretchers, is because we need to guarantee a safety transportation from our modules to any place in the hospital. This not only inside hospital, but also inside the ambulance, because we need to, people must trust the health organization. People at the beginning was really afraid. This was one of the things that was most important, and that I thought a lot about that. Working, to be afraid to work. I think this is something that all of us need to think about. This is our renders about these double 30 beds ICU modules, and this is how we have finished. As I told you, it's already in use. We will go back in the next 2 months. We will wait for 2 months, and then we will go back to ask how are you working? Do you feel we could do something better? How can increase safety? How can do in the next projects? What can we put inside to work better? Actually, now in this second wave, in September month, the government, together with the protection organization of Italy, did a big tender where now the government and the health ministry is not thinking anymore to emergency. It's thinking also how to plan, how to organize the health system for the next 10, 20, 30 years. So all the regions, this is a map of Italy, all the regions have identified all the intensive care units, all the sub-intensive care units, and all the emergency areas in all the hospitals, and there is now a strategy to work and to solve all the problems that all the hospitals have in this moment. So our company, as another companies of engineering and architecture, are working actually to reorganize and to give a good level of safety in all the hospitals in Italy. So from September, we are starting to work in some other hospitals. You see, you finish these design projects. They are already done, and now we are thinking to these new ones. And some of brief examples of these ones are about an emergency area. This is, for example, an new hospital that we have already done, and that in the July month we needed to change immediately to use some part of this building for COVID patients. So in this case, of course, in much part of the world are doing, we needed to think about flows. But I think that it's not only flows. Of course, we need to think about existing medical gases. We need to think about how to increase medical gases point, new air handling unit, new airlocks filters, and also smaller details as doors with video surveillance, how to go inside, if we need to have handles indoors and we need to, or if we need to avoid them, just to assure the safety in these places, how we can take out the waste. We repeat these kind of problems, but we need to see it with a view, a bigger view. Another example in this case is Spezia Hospital, and this is a comparison. I showed you a really small thing, but now we are thinking in a big hospital. In this case, this is a 540 beds hospital. This is one hospital project that we are following in this moment. Is in this case a project. It will be built in maybe in 1 year, but we needed to think already not only in the emergency flows internal the emergency area. This is the project before COVID-19. We didn't have to think about another type of flows. Now we need to have a pandemic strategy, and we need to identify which parts of the internal departments can come in to help in case of a future pandemic situation. So, as you can see, we have observation brave in unit beside the new emergency entrance for, in this case, COVID, but in the future for infectious disease. Which are the intensive care units or the semi-intensive units that can be used also for this purpose? How can we use technology to increase the number of beds in existing infectious disease departments that actually are 15, but in the future they could be 20 beds. So we need to have a plan for hospitals and how they can easily be changed in case of new pandemics. In this case, we add, for example, from emergency area that is in the first floor, we add a new elevator, a new lift to connect directly emergency area with operating theater area. You see, this is connected now with this, with a new elevator. And this is really important because in the operating theater, where we already have 10 operating theaters, we have chosen to dedicate one operating theater with its own flows to infectious disease. So there is a direct connection between emergency and operating theater without risk of contamination in these areas. Another thing is that in the brief observation beside operating theater emergency, we have organized these 18 beds where using different air handling units, we can activate 4 of them, or if we need some other ones, beds, we can activate another 4 to maintaining the flexibility to work with the standard patients with the other 10. Of course, we need to have to increase always now on in our projects 2 places where 2 rooms that can be simple storage, but that in case of needs, we can use it like a dressing or undressing area. The last thing, but not the less important, is how we have feel and how we lived those sad moments. In Italy, as in some other regions, maybe in all over the world, so many people died without having beneath their own relatives. And this is really a very difficult thing to accept. All of us knows that sometimes our affects, our relatives, the love from people that we need beside in those moments is also a medicine, part of the medicine. So it's important to think always about places where we can give information to our relatives, even if they don't go inside. And if we can evaluate that the people, the patient is not really can be only in observation, maybe we need to find a way where we can touch, where we can feel that our relatives are together with us. Wellness, there are different words. There is really a big revolution in this moment about how a hospital could be. We need to think with that, what is Health World Organization is asking us, architects and engineers, to have a vision for the 2030, a different vision. I think that we have a very big work in front of us, because hospitals will never be the ones that we knew in the past. And we need to find a new way to live hospitals in the way that they can be useful to our societies. This is a synthesis for those who work on planning our future cities and public space. The pandemic is both a daunting threat requiring immediate measures and an opportunity to rethink how we live, how we move, and how we can be all together. Thank you very much.
Thank you, Claudia. Thank you, Claudia, for your presentation. I don't know if there are any questions to answer.
We're not seeing any questions at this time, but are there any questions that anyone would want to pose right now? If not, we will move on to the next session.
Okay.
Just before, sorry there, Enya, just before we move on to the next session, I just want to thank Claudia as well for her presentation. Very, very, very informative, and I'm sure we have gotten a lot from what she had presented. I also want to remind our attendees that the presentations and this webinar in full will be posted on our YouTube page, that is YouTube page, I'm sorry, for the Jamaica Institution of Engineers. So you can just subscribe to our link and to our page, that is, and you'll be able to have access to the full webinar when this is completed. So since there are no questions, I suppose
yeah, we can start with the last session. That will last about 30 minutes. Our Marcello Gusso, Chief HVAC Engineer, will introduce the COVID engineering presentation from our experience. Marcello, please, the floor is yours.
Yes. Do you listen to me?
Yes.
Okay, probably now you can see the screen.
Yes, thank you.
Okay. So good evening to everybody. I'm very happy to stay with you. I will try to be very clear. So this is the topic 3, which involve essentially two topics. One is a room air quality and pressure control in the intensive care unit for COVID-19. The other one is the medical gas supply, which is a very important issue because in the COVID patient needs a lot of oxygen, needs a lot of air and whatever. So it is a critical issue you cannot use the value that are normally utilized for the normal patient. This is an image of Bajubara installation that has been already described by my colleague, and I will take an example with Bajubara in this presentation. So this is more or less a summary of the airborne infection isolation room design standards in various countries. As you see, it is not a constant reaction to the problem. So there are several parameters that are not all the same, as you see, about pressure, about air change rate, and let's say about HEPA, high efficiency filters and whatever. What probably is to be taken as a reference is the HRI 170 standard that require a pressure difference of 2.5 Pascal, negative pressure for the COVID-19, and an air change of 12 air change per hour. So, of course, this is under pressure in case of infectious people and over pressure in case of immune suppressed people. As you see, there are two types of intensive care unit. The one which are dedicated to the airborne infection isolation rooms for infectious disease. So people that could infect other people. And so in this case, the room must be kept in under pressure. So we must avoid that the air that is inside the room goes out in an uncontrolled way. The other type of intensive care unit is the protective one, where the patient are immune suppressed. So we have to protect the patient from outside virus and bacteria because they are very weak. Probably they come out from an operation, or anyway, they are immune suppressed. So we have to protect them. And in this case, the pressure must be higher than the surrounding rooms. And the minimum is at least 2.5 Pascal. However, in our application, we have applied not 2.5 Pascal to calculate the flow rates and the flow rate difference between supply and return. We have assumed plus or minus 5 Pascal, according if it is protective or isolated room. So this is to stay on the safe side, because you know it is very frequent that there are some cracks or imperfection in the envelope. So we must have a certain redundancy in the flow rates. So if we start with 5 and it's okay, we should get 5, but at least we have not to go below 2.5. This is the minimum, absolutely the minimum. Okay, so why do we need, let's say, we need to provide a different supplier flow respect to the exhaust airflow. So the example that is now shown is the negatively pressurized room. So this is for COVID-19 intensive care unit. So the supply of the air to the room is lower than the exhaust airflow. In this way, we will have an under pressure inside the room, which is covered by infiltration along the border of the door, or at least some imperfection of the envelope. So in general, the most important thing to take in consideration is the gap that there is between the door and the frame of the door. So that is the main cause of the infiltration of the air. And according to HRI, the relation that allow you to calculate how much is the infiltration is given by the equation which is up there. So this is an international system, of course, liter per second, square meter, and Pascal. Of course, there is even the US units expression, of course, in the same report. There are both. You can see it. So it is very important to have a door which is very well tightened to the frame, and so you will have a lot. The gasket all around must be of high quality, and then another very important thing is to control the infiltration on the bottom of the door, which moves over the floor. And so in this case, it is essential to have a sliding gasket like this that moves up and down and keep the gap closed, at least closed. So it is anyway a gasket. It's similar to a gasket. Of course, it can move, slide over the floor, but it's very important. So this is an infection isolation room where we put the COVID-19 patient. As you see, the pressure inside the patient room is minus, means the lower pressure. This means 2.5, but in our calculation, 5 Pascal of under pressure. As you see, the supply is positioned more or less close to the door, while the exhaust is positioned on the other side of the room. So the clean air moves in this direction and protects the patient, and then is extracted outside. The anteroom is in general at an intermediate pressure between the lowest, which is inside the patient room, and the neutral, which is the corridor. So it is in the middle. And we have, of course, to control if really there is this under pressure. If we go ahead, this is an example that we applied in one of our applications of one of our hospitals. In this case, there is a difference respect to this scheme. As you see here, the anteroom is at an intermediate pressure, but in this case, the medical staff of the hospital asked to us to provide the lobby. This is the lobby or anteroom, as you like, to provide this lobby not at the intermediate pressure, but at a higher pressure, to provide this lobby just like an airlock. Because when you provide an airlock, you have a pressure which is higher than all the room outside, all around. And so in this case, we have minus 5 Pascal in the room. This is the room where there is a patient, and plus 5 Pascal in this airlock. So we are very, very sure that there is no infiltration from this room to the airlock and then to outside. This is a variation, another option that can be applied, depending on the experience of the medical staff of an hospital. Not everywhere they think about these issues in the same way. It is also a problem of tradition, of procedures. So it is not always the same, but more or less it is, but not for the details. So you see here there is a supply, the supply diffuser. Here there is the return extraction diffuser. So as you see, the supply is close to the door, the return is on the other side. So the bed is, let's say, washed by the clean air and then extracted. This is a typical air handling unit that it is utilized for infection isolation department. Of course, we must provide a unit for this department and only for this department. The air handling unit cannot be in common with other departments. We must absolutely avoid that, because could be some mixing phenomena or some air that moves to other not protected area where there is no procedure to protect the patient. And so it could be very dangerous if you use the same unit for isolation and for the normal wards, for example. So you must dedicate a special unit for isolation department. And this is the case. It is always in this way. This unit is provided with a HEPA H14 filter at the exhaust. Because of course, when the return air coming from the infectious patient rooms, of course, can carry with it some viruses, which are generally connected to a particle. So we get the particle and we get the virus. So we clean so much there before to exhaust it outside. It is important to have here, where there is this filter, which is the most important, the most dangerous of this unit, to have a bag in, bag out canister, to have a safe substitution of the filter. So it is not just like a normal filter. We must have a system that you push the filter from one side and you put in a bag on the other side without touching with your hands. And so then you substitute with a new one, which is of course not dangerous because it is still clean. As you see, there are all double fans. So if there is one that breaks, there is the other one that can guarantee at least 75% of the flow rate, but better 100%. The heat recovery is made by run-around coil like this. You cannot have in an infectious isolation department, in these high care departments, you cannot have a, let's say, cross-flow heat recovery or rotary heat recovery, because could be a certain bypass between supply and return. And this is absolutely not allowed in this case. And so we use the heat recovery made by two coils. So there is no mixing, absolutely impossible to have mixing and to have cross-contamination. This is the protective isolation room where the patient room is over pressure, let's say, as usual, +5 Pascal. The anteroom in this case is neutral, but it is not always in the same way because there are some different experience among the various hospital staff. However, the patient room is absolutely at higher pressure. The supply is made on the side far from the door because we have to protect the patient from the bacteria and viruses that can enter from the door. So the direction of the flow is to be made from the patient bed to the door. And here there is destruction. This is an example of intensive care unit for protective scope. And this is not a lab, this is a control room to, and here there are the doctors and the nurse that control how is going on for the patient. This is the supply, you see, is on the external side of the room, and then we make the supply. This is of course provided with HEPA H14 filters. And here there is the patient, and here there is the extraction, which is made with two grills, one close to the floor and one close to the ceiling. It is more or less like the operating theater to have a uniform flow of the air. We provide this two differential extraction at two different levels. Yes, here there is the HEPA H14 and it's okay. Okay, this is the unit that is provided for the protective isolation department. And even in this case, it shall be a dedicated unit. You cannot mix with other departments. You can make a unit which is modular type as usual, or you can also provide compact pre-assembled type. As you see here, this is an example because when you have to go fast, you can spend more providing, purchasing a compact system dedicated to this scope, which is already pre-assembled, checked, tested, commissioned in factory. So you have just to put it there. It's a plug and play solution, more or less. This is very quick and is very important when you are in a hurry, of course. But of course you can use this solution, but even the usual modular construction of the air handling unit. Airflow tracking, of course, to provide the pressure inside, negative or positive. The way is to control the airflow that is supplied to the room and the airflow that is extracted from the room. This is made by VAV systems, variable damper, that are controlled by BMS. Of course, if you want to have an under pressure, for example, like in the COVID-19 intensive care unit, and like as it is described in this sketch, you see there is the air that infiltrate under the door and enter inside. So we have an extraction which is higher than the supply, and in this case you will have an under pressure inside here. And what is the most efficient system to control the pressure inside? You could check it, you could test it by a differential pressure transmitter and try to control the flow rate, trying to check, I mean, to have the right pressure inside. But as you have seen, the differential pressure value is around 5 pascals. So it is a very low value. So you would need a so precise instruments, and could be some imperfection in the adjustment that could have bad effects in the regularity of the flow. So this is not the way to do it. The way to do is when during the commissioning phase, you have to check exactly what is the proper flow rate supply and return to provide the proper pressure. And then checking that, you can provide the pressure in an indirect way. So you have to control the flow to control the pressure, because it's more precise to control the flow in a VAV system, where the flow is measured very precisely, than to control directly the pressure. Of course, you have to provide a differential pressure indicator to check if it works correctly, but it is not utilized for the adjustment. It is just utilized for indication. This is called airflow tracking, and is always utilized in this way. As you see here, of course, you have to check the airflow to provide the pressure, but you have to control if the pressure is there. So it is an indicator. It is not a system that is directly connected to the adjustment, but anyway, you must provide an indicator, which is located inside the door, visible from the corridor. Can be an electronic system like this that could be connected to the BMS, could have alarms and whatever, but could be even a purely mechanical system like this, which is Dwyer anyway, the same manufacturer. So this is electronic and this is mechanical. This costs more than 10 times than this, and this is one problem. The second is that probably in a retrofit of a hospital, it is very easy to provide a mechanical system. It is maybe less easy to provide an electronic system to be connected to BMS and whatever. So, well, it is, in general, we use the mechanical one because it is very precise. The solution is very precise. It's better, even better than the electronic one. There are no problems of electronics that sometimes happens. And so you can choose. You can choose. If you have money, the BMS is in your hospital, you can provide the electronic one. Otherwise, you can provide the mechanical one. But at the end of the story, there is also this check that has to be made with a smoke. You can do it even with the cigarettes. So this is very important because you can see in a visible way how everything is working. If the distribution of the air is okay, is not a quantitative, but it is a qualitative check. But it is even important. If you have a certain experience, just with the smoke test, you can understand if everything works well, at least preliminarily. Then you have to do the measurement and whatever, but you immediately understand if everything works. The type of diffuser that we generally use is a system like this, which is provided with the H14 HEPA filter inside. You see here, this is the filter which is included in the diffuser. This is a particular diffuser. Halton is the manufacturer, is a Finnish company. This is very nice because you can adjust the position of all these nozzles. You can rotate and adjust the position to avoid the downdraft of the air on the patient or whatever. You can adjust the flow all around the room, and so this is very flexible. You can have a swirl effect or a radial effect as you like. So it is very flexible, and I suggest to use this kind of diffuser. This is an example of a construction we did recently. This is the Bajubara Intensive Care Unit. COVID-19 is the one that we have seen in the first picture, and also Claudia described before. So this is a view from the top. Still, there is not the final fence, there is just a provisional fence, but this is completed anyway. Here there are two air handling units. One is to supply and return of the air from the service rooms, which are located here below this roof. And this one is, on the other hand, the air handling unit that provide the air conditioning to the intensive care room, which is this. It is a unique room with 18 beds. So in this case, you don't need to have the VAV, because of course, due to it is a unique room, it has a unique pressure, only one value of the pressure because it's a room, it's a node. We will adjust the pressure utilizing the speed of the fan. So we can increase or decrease the supply and return fan to have the proper pressure inside. It is very important to have good tightness of the window and of the doors, because if there are cracks or imperfection, it could be difficult to keep the proper pressure. One thing that I would like to say is, it has been asked to us to provide a system that can be reversible in the future, moving from an intensive care unit for COVID-19, which is under pressure because they are infectious patients, to an intensive care unit for normal use, which is generally over-pressurized because they have immune suppressed people, or let's say weak people inside. So this is absolutely possible because we can, just adjusting the speed of the fans, we can change the pressure inside. So we can increase the supply and reduce the return, and we increase the pressure inside. The opposite to decrease the pressure inside. However, one very important thing is that you can use it for COVID-19 under pressure. You can use it for normal intensive care unit over pressure, but you cannot use for both together. So you must decide if you want to move to the other mode of operation. Then you have to clean up everything, to disinfect everything, and then you can go in the other mode of operation and stay there. It is not so easy to move from one mode to the other one very quickly, even because this is a unique room. Inside here, this is a plan, more or less. We have already seen even some 3D drawings. As you see here, there is a supply. So the supply is concentrated in the middle of the room. This is the intensive care area. And the return, so the extraction is concentrated near the beds of the patient, so that we have more or less a clean area in the middle. So clean area maybe is too much, but however, a less risky area in the middle. While if you approach the patient and when you are close to the patient, this is a more risky area because of contamination. And over there is destruction immediately. So the people that work inside this department can stay a little more calm, let's say, less stressed in the middle when they are on the computer and when they prepare something. And then they have to concentrate and to be more, let's say, afraid sometimes when they are close to the patient. This is the distribution in the files ceiling. As you see, there is the air handling unit supply in the middle, and the extraction is made on the over the beds. And this is a view from the top, where you see the roof, of course, of the building. And here there is the external area where you see a technical room. This is the chiller, this is the heat pump, and this is a system which is chiller heat pump together. It's a 4-pipe system. Then there are the 2 air handling units, and this is a water treatment for the sewage before to drain the sewage to the hospital network. So we provide the disinfection of this type of sewage. Other issue, very, very important, are the medical gases. In this intensive care unit, we have three gases: oxygen, medical air, and of course, vacuum. As you see from this table, this is the table which we have done for Bajubara installation, where there are 18 beds, and you see there are 60 liters per minute of oxygen every bed, with a diversity of 1, so 100%. You cannot, for oxygen in this department, you cannot apply a diversity else than 100. You must have 100% of activation of all these outlets. So the total flow rate for 18 patients is quite huge. This has to be taken very much into account when you design this, because generally in a normal bed, in a normal ward, you have 10 liters per minute per patient, not 60. But this is very important because they use some devices for the people, respirators or whatever, that sometimes need a lot of oxygen. All the outlets are doubled, so you have 2 outlets per patient for oxygen, for medical air, and for vacuum. Of course, for oxygen, there are 2 outlets of 30 liters per minute each. So the total is 60. They can use 2 if they need. On the other hand, for medical air and vacuum, we can apply a diversity. This is a diversity which is the proper one for intensive care units, and is taken from the British standard, the HTM 0201, which is often used even in Italy, to define the diversity. However, the single flow rate for the patient is quite high, and the total flow rate is even quite high. Okay, this is an example of distribution, of the distribution scheme. The central stations are located here on the left, elsewhere. We will provide emergency supply because you cannot stay without gas. It is impossible. So if you have problems, you must call the truck, the cylinder truck, and then connect it immediately, the emergency for medical air or oxygen, if it is necessary. Then you see here, each bed is provided with columns, I mean with the units you have seen before. So there are 2 outlets for each gas in the column. The piping is quite big because, as you see, for just 18 beds, you have here 35, 42 millimeters of diameter. And even this derivation is quite big, 35, 28, 28. So it has to be taken into account very well. The flow rate is high. And essentially, we will provide the emergency supply outside the building in a position where the truck can arrive very easily. Then we have the alarm at the entrance of the department. We have shut-off valves. Here there are the second stage pressure reducer. In Italy, we use so much the second stage reducer. In the installation made according with British standard, or in general in the English tradition foreign countries, they don't use the second stage reduction. Everything is made by the first stage reduction, and then there is just the distribution. This is a different philosophy. Both of them can work. The only problem is to provide the proper diameter for the proper flow rate. Then there are the alarm system even inside. There are 2 alarms even inside. And here is the picture of the of the column, which is dedicated to each bed. And so alarms of this type, but can be of several manufacturers, no problem. So I thank you very much for your attention. If you have questions, I am here trying to answer your question.
Thank you, Marcello. Thank you, Marcello. Thank you very much. Okay, so before getting to the questions, we wanted to try to send the video of the construction of the Bajubara facility that you have seen, and Claudia will try to launch the video while I'm talking. It's supposed to be a video without sound, but it's a time-lapse video, so very, very informative. And after the video, I would ask Marcello to answer a question that I think it's for him. That is, in light of the under-designed pressure isolation room, what are some practical remedies which can affect similar long-term protection? And this is specifically in regards to achieving negative pressure. So this is the question for Marcello. And we see that there is another question. Is it possible to get a soft copy of each presentation? Yes, it is, of course. So once we finish the webinar, we will collect the documents and then we will send them to JIE for their distribution. JIE have all the emails of the attendees so that it can be an attachment for the email. Let me check if the video can be launched or not. Claudia, just a moment. Well, in the meantime, okay, maybe, okay, we have the screen. Let's see if the video can start. Here we have, okay, should be, okay, this is the video. And it's the time lapse of the construction of the COVID facility that was external to the hospital, to the existing hospital. And you can see here from the brownfield till the end of the construction. So it's a time lapse, so it's not, of course, a continuous registration, but well, you can see in a few months what happened according to our design, the preparation of the sites, from the excavations to the casting of, not foundation, but of the platform that was mainly used to host the technical systems, as of course it was not necessary to have a particular foundation. And there you can see the prefabricated modules being mounted, and it was really a quick installation, and it was, well, the groundbreaking ceremony was maybe after 2 months, the start of the works. This is the installation of the technical part, so the technical spaces for air handling units. As you can see, the air ducts are being mounted. We have here ventilators, and here we have the final installation at the end of the works. These are the beds that were shown by Claudia before. And this, of course, is the days for the authorities opening. It was immediately used as a regional center for, as a regional COVID hub for regional patients, giving a huge relief to the existing hospital. Okay, and this is the final situation as it is today. As it is today, and it will be kept also at the end. Okay, thank you, Claudia, for sharing the video. Now I would kindly ask Marcello.
Yes, I have to. Yes, okay. I have to share the video again.
Yeah. Did you see the question?
Yes, yes, I've seen the question.
Okay.
I don't know, can you see my video?
Yes.
Okay, so I start from the beginning because I want to show you one thing. Okay, as you see here, the HVAC standard, United States standard, is for 12 air change per hour. Well, what I understand from the question is, under design isolation room means that you probably have not enough flow rate, or you might have problems of cracks in the envelope or something like that. So this is what I expect could be defined as under design, because you have an existing hospital, you have an existing situation, and you have to work with that. So as you see, it is not strictly necessary to have 12 air change per hour. You can work even with 9 or 10 according to other standards. Well, if you go to look in more detail to the standard, even the USA standard, you will find that in case of existing hospital, even 6 air change per hour are possible. Less than 6 is probably impossible to do a good job. Even with 6 is not easy to arrange a good solution, but anyway, it is admitted in case, it is allowed in case of existing hospital to have even 6 air change per hour. So the other thing is, even if we design with 5 Pascal of under pressure, because we want to do it, or even because there are some other regulation that require 5 Pascal, but according with the United States standard, it is 2.5. You can even have 2.5. So you can have half of the pressure, of the differential pressure that we generally provide, and you are still in more or less a proper situation, even from the standard point of view. Then at the end of the story, if you really are in great difficulty because of the tightness of the room, because if the room is not sealed correctly, if it has a lot of cracks or infiltration and you cannot solve it, of course it's impossible to have a good under pressure inside. But at least you must have a flow rate. Of course, this is not a situation that is acceptable, but sometimes it is impossible to do something else. So in this case, the important thing is when you open just a little the door, that the air moves from outside to inside along all the gap of the door. So of course, the last one is very critical situation, but it's better than nothing. So this is more or less what you can do. Of course, if you have a department to be made properly, you must invest some money and make it or a new one, or retrofit this department, providing a better isolation, a better tightness of the envelope and of the door and of the windows. It is not so difficult to provide a good door, because if you have to remove and put a new door, well, it is not a so big job to do. The rest of the cracks can be investigated and found and closed in such a way. So this is the way to go ahead in this condition.
Okay, thank you, Marcello. Thank you, Marcello. So we have 2 more questions, I think, for Claudia. The first question is, has Politecnica or the Italian health sector utilized field hospitals? In Jamaica, we have used the same. Claudia?
Yes. Okay. Yes, in Italy, there has been, in particular way, in this second wave, we are using field hospitals also in 2 regions, in Campania and in Calabria. there is a very big difference between first and second wave. The first wave, it was the COVID contamination was all centralized in the north of Italy. Now, in this second wave, we don't have answers for this. It's all in the south of Italy. So the government help was directly oriented just to the north at the beginning. Now we have two problems that we have to organize the south. So we are using, this is the 8th. We have 8 field hospitals, but we have a big problem that field hospitals are a complication because now we are in winter. So it's a double situation to solve. As I was telling before, we need to think not to the emergency, we need to think to the future. So even if we are solving a situation with field hospital, this is not the correct answer. In this case, I think my personal opinion is that it's better to think about to use an sport structure, a place where you already have the flooring and you have the ceiling, instead of using field hospital. Actually, we have been helped also by emergency organization to solve this problem in the south of Italy.
Okay, thank you, Claudia. We have another question that is very, very general, and maybe we can give our opinion. Of course, the question says, while an immediate answer may not be available for a country like Jamaica, where resources, challenges, financial, mechanical equipment is an issue, what suggestions can you make for our immediate applications? This, I would say, it's a $1 million question, because every country has limited resources. Actually, I must say that also in Italy, when there is an emergency like this, is really very difficult for everybody. So I don't know if we can give an answer for the specific context. We may give, Claudia maybe can give our opinion on the solution for immediate applications, or the fastest applications that may give you some inspiration, I would say, because the answer is really difficult for this question. Thank you. Claudia, please.
Okay, thank you. I think at the beginning, if you look, and you can find the document that has been delivered by the health organization, World Health Organization, there is there is a book where they talk about how to organize, and they have put examples to how to organize new hospitals or new structures or existing structures, thinking on the different situations all around the world. I think this could be a good guide, but in my opinion, I think that we can do half of the prevention following really with discipline protocols. As I was telling you before, in an emergency, we can use trolleys for ventilation. We not necessarily need to have handle units inside, because we understand that it's not easy and we cannot have them every moment. But we can try to maintain hygiene, to respect hygiene protocols, washing hands, covering, maintain distance. I think we need to limit the contamination, and who is the factor that can contaminate? Is the staff that is working inside. So I think that, in my opinion, is to analyze our working process, what are we doing, and how are we doing it? Because in one of the images that I showed you at the beginning, in those places, in that hospital where we have people dressed and people undressed in the same room, we have not have any member of the staff contaminated, and they were in the same place. So, to respect hygiene protocols, to respect distance, washing hands, procedures. We need to analyze what are we doing, how are we doing, and we need to analyze the risk that we are having doing things in that way.
Okay.
It's not necessary to have all the equipment and all the elements that we have seen today, but we can analyze what we do. Thank you.
Okay, thank you, Claudia, for the answer. We have another question on engineering system for Mr. Marcello Gusso. The question says, I noticed that for the infection isolation department, the air handling unit returns the air from the space. It is idly filtered. However, in what cases do you use a 100% fresh air system? Please, Marcello.
Yes, we always use 100% fresh air system. It is absolutely forbidden to have recirculation in this kind of department, because you could have an infection that you can see my screen. Can
Yes.
you see the screen? Okay.
Yes.
Because you have not to spread the infection in other rooms, so you must absolutely avoid to have mixing of air that goes to other rooms coming from some patient rooms. So it is absolutely not convenient and not allowed to have mixing. So it is always 100% fresh air, as you can see here. As I said before, even the heat recovery is made by double coils, run-around coils, as you see here, here, and here, just to avoid any possible cross-contamination of the supply flow, which is clean, and the return flow, which is, of course, unclean, and possibly risky, let's say, risky flow. So no recirculation, always 100% of fresh air.
Okay, thank you, Marcello. So I don't see any more question. So I would say, Marcello, can you give me the screen? Can you just?
Yes, sorry. Quick. Stop share, yes.
Okay, just a moment. Okay, so I think, Mr. Tai, if no more questions are in place, I think we can conclude our contribution. So, of course, it was a very short presentation because, of course, we could not address all the topics that are in a complex facility like a hospital, but we hope that could be inspiring and could give an additional insight on what we did and on the possible solution. Of course, you can make a reference to JIE. I put here the data of the Jamaica Institution of Engineers. Our information as well. Of course, we are available for any brainstorming or follow-up that you may need. So feel free to contact JIE or us in case you need some more detail or you want some additional information on any topic that you've seen. We'll send to JIE the material for the distribution that you just saw, so you can see again a soft copy, in a soft copy all the topics that are presented. So I would thank again JIE for hosting this webinar that was very, very interesting also for us. So I would leave the floor to Mr. Tai. Thank you again.
And I want to say thank you very much to the team from Politecnica, Enya, Claudia, and Marcello. Very, very informative presentations, though we didn't, as I said, may not have had the opportunity to delve into many of the technical nuances that you would have wanted to. I'm sure that the information that you have presented will inspire a lot of thought within our engineers and our architects and our healthcare personnel as to how we can better position ourselves to respond to COVID-19. And I just want to echo your sentiments as well, that the information presented here is available for sharing. We will have the entirety of this presentation on our YouTube page, or JIE Jamaica Institution of Engineers. And as well, you can email us and we can put you in contact with the team from Politecnica should you want any clarification on any of the issues that were discussed, or if you want any additional information whatsoever, we can just create that link. So again, I want to thank the team from Politecnica. I also want to thank JIA, Mrs. Denison Heron for her statement earlier. I want to thank Mr. Marlon Jones from the Ministry of Health and Wellness. And I want to thank all the participants who came out and participated in some way or another, whether it is just to get the information or whether it is to pose their questions. We really appreciate everyone taking the time out just to join us. And we look forward to further opportunities to share our experiences and share our knowledge. I mean, this is a perfect opportunity for us to collaborate and really just to ensure that everyone has the information and the requisite advancements in knowledge and practices so that we can move forward in fighting against this pandemic. So thank you again to everyone, and feel free to reach out to the JIE and we can share whatever information you may require. So that's it from us, and we'll be in touch.
Thank you.
Thank you. Goodbye.
Goodbye.
Good job.
Thank you. Bye-bye, everyone.
Bye. Have a nice time. Thank you.
Thank you. Thank you.
Bye.
Thank you. Thank you all. Good.